Hello, Matrix, and welcome again. Today we're going to be doing financial maths. Now, if you saw my last video on financial maths, I went through the different formulas that you need to know for your final matric exam. Now I'm going to put them into practice a little bit more using a past paper question, which I think is a really good question because this question here uses a lot of the different formulas. So what I'm going to do is go through the question and then we can identify where we need to use the different formulas. So this is question 7 from, I think it is the 2018 or 17 paper, but don't worry, I'll put a link to this paper in the description below and you can check it out yourself. All right, so it says on the 1st of June 2016, a bank granted Tabiso a loan of 250,000 at an interest rate of 15%. And compounded monthly to buy a car. Tabiso agreed to repay the loan in monthly installments on the 1st of July 2016. Okay, so just a little note, you always start paying a month after you take the loan, because if you think about it, why would you pay on the day that you took the loan? Because then in theory, say you borrowed 10,000 Rand from your friend. And then he said, well, pay straight away 1,000. Well, then you're actually just borrowing 9,000, right? So really the payment starts at the end of the month. So just remember that payments start a month after the loan is granted. And that formula for the payments formula, that takes into account the fact that the payment is a month later. Right, so Tabiso ending 4 years on the 1st of July. Okay, so he's paying off the loan in 4 years. However, Tabiso was unable to make the first 2 installments and only commenced with monthly installments on the 1st of September 2016. Okay, so if you take the loan out on the 1st of June 2016, you'll pay on the 1st of June 2020, that'll be 48 payments. So let's have a look now at the first question. So it says, calculate the amount that Tabiso owed the bank on the 1st of August 2016, a month before he paid the first installment. So basically what they're saying is he didn't pay for 2 months. And so what is going to be the balance of the loan after that? So this is a classic question where they're asking you for the future value of a loan. So even though it's only in the future is only 2 months, it's still the future value formula. So what we must do is we must go to our formula sheet. Now, as I explained in the last video, these are the different formulas. I've left out one of the simple interest formulas. This here is the future value. This one here, future value of a loan. Okay. Because it's a plus, it goes up, and because it's compounded, it goes up each month. And so what this really is asking is, so 7.1 is asking, how much is the month going to, how much is the loan going to be in 1 month time? So we're going to say A equals, right, the present value of the loan is 250,000, right? June, July, August is going to be 2 months, right? So we're going to say 1 plus, now the interest is 15% per annum compounded monthly. So we say 15% over 12 because it's monthly. And then the N is 2 because they're asking for it in 2 months. So this is an example where we're using the future value of the loan. So we've already now used this formula in an example. And so what we can do is we can put that into our calculator. 250,000, open brackets, 1 plus, and now you could do this 15% as 0.15. Oh, I need to actually go and just get this back into computational mode. Okay, 250,000. That was previously in stats mode. So if you get a thing where it's not showing the fraction, just say shift mode and 1, and then it'll take you back to the correct format. And now we're going to say 15. I don't like to say 0.15 because sometimes students get confused and they'll put like they'll get the decimals wrong. So if you say 15% using the percent button, you can't go wrong. And it's over 12 months. And this is in 2 months' time. What is it going to be worth? Okay, and it'll be 256,000. 2562890.06. Put the rands in there. All right, so we've used the future value formula. Okay. So again, if someone said you take out a loan of 250,000, what's it going to be worth in a year's time? If you don't make any payments on that loan, you're going to put in this formula, but instead of 2, you'll put 12 because that's in a year's time. It'll be 12 months. Okay, now the next question says, having paid the first monthly installment on the 1st of September, that makes sense because the loan is on the 1st of August worth this. So then you will pay a month later because you always pay a month after you take the loan. So it's as if he's taking out the loan on the 1st of August. So we can think of this question as the loan was 250,000, but rather than think of it now as the loan is actually 2568906 taken out on the 1st of August. Having paid the first installment on the 1st of September 2016, Tabuso will still have his last payment on the 1st of June. Calculate the monthly installment. So what we have to know here is that it was 48 months. He skipped 2 months, so it's 46 months, but we treat it as if the loan was just taken out on the 1st of August. So we are going to use the paying off a loan formula. So in the previous video, I said, when you get the payments formula, think of if this is the future value. So this is like when you take out an investment. Okay. So F, future value, taking out an investment. And when you see the P, just think paying off a loan, right? Just think P, paying off a loan. So that's a way to remember which equation to use. All right. So 7.2, now he's paying off this loan and they want to know the monthly installment. So of course, we're using the payments formula, P, paying off a loan. And so this is the P is the loan that he's paying off. So it's actually he's paying off this 256,289,06 equals, and now our X. Okay, now if you watch the last video, I didn't show how we would solve for X. So this is an example where we're actually going to now solve for X. So I'm going to put X in yellow, I mean red. And then it's 1 minus 1 plus, and the interest is still 15% over 12, but now it's to the power of, and it's 46 months because he skipped 2, divided by 15% over 12. Okay, so now what a lot of students battle with is the calculator work on this. So the easiest thing to do is to simply just work this out and this out as a number. And so it's then, you've simplified it a little bit. So let's do that. So what we're going to do is we're going to say, so we're first going to clear. If you already know how to use your calculator on one of these questions, you can maybe just skip ahead because I am going to take a bit of time over this because it is important to get the calculator work right, because if you don't, each question follows on from this. Okay, so what we've got is, let's clear this. So I'm going to take everything except the x on the right-hand side. So it's going to be open brackets, 1 minus, open another bracket, 1 plus. Now we've got some fractions there, so it's 15% over 12. So you could do this all in one step, but because this is worth a few marks, you really don't want to be making a mistake. So I like to do this in 2 steps. And so again, that's in the brackets. So theoretically, what we would actually be doing is saying, to get x by itself, we'd say 256 divided by this whole thing here would give you the answer, but I'm still going to do it in steps. So there's the percentage over 12. Okay, now for those of you who want to do it in one step, to get x by itself, all you're doing is you're simply doing this 256 divided by this to get x by itself. So you would say 256 289.06 and with 0625. So we can actually put the 0625 there, divided by that whole thing. Oops. Okay, we need to close our brackets here. And we get payments of so to yellow, because it was solving for x, we get x equals 7359.79. Okay. Now, for those of you who don't want to take any chances, you would say then what you would have done is 256,899.06 equals, and so you wouldn't have put in the the 256 first. You would have just done this. So then you get equals x 34.822. Let's make it, we'll stop there, we'll make it 9, round that 8 up. And then what you could just do is say 256,289.0625 divided by 34.8229. Okay, equals. And we get the 7359.79. Okay, so it works both ways. It just depends on how you understand it, how you want to work with your calculator. But as I said, you can just do this by itself and then the other individually to get to there. And that's probably the most simple way to understand it. But if you do get this financial math stuff and it comes easy to you, then you can just do it the first way where you type the whole thing into your calculator. For those of you who have special calculator just solves it without having to do the thinking, well done to you, but yeah, I think it's better to understand it and to think. All right, so now what they said is if Tabiso paid 9,000 as his monthly installment starting on the 1st of September. Okay, okay, so remember I just wanted to make a note. So remember we were using this paying off a loan formula in yellow. Okay, so paying off. So we weren't investing the money, we were paying off the loan. So P paying off a loan. So that's when you use this one. Okay, so I've color coded it. Yellow, use this formula, and then blue, use this. Now we're saying Tabiso paid 9,000 as monthly installments starting on the 1st, and how many months sooner will he repay the loan? So again, we are still using the P formula because he's paying off a loan. Okay, so 7.3, he's paying off a loan. And so we're going to say, well, he's still paying off the same loan, right? The 256,289.06. But he's paying 9,000 Rand a month. So we know the payments. So the payments is actually 9,000. So our N is going to be what we sold, because we want to know, well, how soon does he pay off if he pays 9,000? So again, 15% over 12 to the power of minus N, we don't know, over, and then this is 15% over 12. Okay, so once again, we are in a situation where we need to get minus N by itself. Okay, so let me actually do minus N this time in red, because that is what we are wanting to get now. Minus N. Okay, so once again, I'm going to just use my calculator here, and I want to make it as simple as possible. So what I'm going to do is I'm going to say the 9,000 divided by this to figure out what this is here. Okay, and then to get this by itself, I need to basically divide 256,000 by the 9,000 over this. So in other words, if I divided both sides by, I'm going to draw it and then erase it, but say I need to divide both sides by 9,000 over 15% over 12. If I do that, then you see that that cancels. So the yellow cancels the white on the right, and I'm just left with this value here, and then now this, which I'll then have to solve further. Okay, so what I want to do is figure out the, I'm going to get up to the point, I'll make it in red. I'm going to kind of get this bit by itself, whatever I've got in red, the brackets bit and the minus N. Okay, so let's see how I put that in my calculator. So we'll say, so we'll clear what we've got. We're going to say 256,289.06. And then we're on a new question, so I'm not going to use 0625. And I'm going to divide by, now, I'm going to use this bracket symbol. And at the top, we have a 9,000. And at the bottom, we have a 15% over 12. So I can just make that 15% over 12. Okay. And so I get 0.325. So I'll put that in here now, in yellow. So 0.35595.7. So 355,957. 355,957 ... equals, and then it's 1 minus 1 plus 15% over 12 to the power of minus N. Okay, now this is actually a square bracket, and we see that actually this here goes like that. And so this square bracket, I can technically just drop the red square brackets. Do you see that? So what I end up getting is, so when I erase this red, that's my baby in the background, by the way. I'll show you a picture afterwards, so you don't think it's anything weird. And right, so we take the 1 across, and so we say 0.335 minus 1, okay? Equals, and so we get 0.66 0.644 equals, and that's a negative, 1 plus 15% over 12 to the minus n. Okay, so now we are ready to solve for n. Okay, and you just need to remember, so I've done a video on logs before, so I'll put a link into the description or onto the screen now for the logs video if you need to look at that. But logs, you just need to remember the following: log base number equals exponent. Log base number equals exponent. So let's go. Log. Oh, by the way, I'm going to solve for minus n, so let's just keep this minus n in red. Log base. So the base is the bit in yellow, because the base is the thing at the bottom of the exponent. 15% over 12. Number is the number by itself, which is this. Negative 0.644 equals, and then the exponent, which is minus n. Okay, so now what I can do is I can put that into the calculator. Oh. Except, of course, I need to just make sure. So this was a negative here. So there was the 1 minus. So of course I can cancel the negatives here. So that one cancels with that one. So this was actually a plus here. Okay, so now I can put it into my calculator. So I'm going to say clear it again. And I'm going to use this button, log. And then this allows me to put that whole thing in 1 plus the brackets 15% over 12. Close the brackets. And then over here, I'm going to put my 0.644 equals, and I get minus, well, I get minus n, which is good. I want to get minus n, as I want to get the answer as a negative, because then I know n, if I divide both sides by -1, I simply get positive. So n is equal to 35.42. And of course, there's going to be a final payment. So whatever this is, I always round up. And so it's 36 payments. So he paid 36 payments instead of 46, because remember, it wasn't 48, it was 46. So he pays it 10 months sooner. So I'm going to put that here, 10 months sooner. So I want to have a bit of space. Okay, now the last question, 7.4. So this again used the payments formula, paying off a loan. This says if Tabiso paid 9,000 monthly installments starting on the first, calculate the final installment to repay the loan. Okay, so this is a very common question. It's often the balance outstanding question, and I'm going to do a video on the balance outstanding of a loan as well, just because this comes up a lot. But basically what we need to do is, if he's going to pay this 9,000, we want to know the final installment that he needs to make. So what we do is we know that he makes 35 full payments until he has the final payment, which is a smaller payment. So what we do is we get the loan amount, right, which was the future value of the loan in blue, right? And so that would be, it was 256,289.06. And we found out, well, what is that going to be worth in 35 months? So when he makes the last payment, not the last payment, but the last full payment. And that's going to be 1 plus 15% over 12 to the power of 35. Okay, now that's going to tell you the loan value at 35 months. But of course, he's made payments. And so now we finally get to use another formula, which is the future value of the payments. So in other words, because you are giving interest to the loan, you're saying that this value in blue here is assuming that he didn't make payments. But of course he did. And so had he invested that money, he would have earned interest. So technically, you can't just charge him all of this interest here. So you'd have to take it off. And the way they do it is saying, well, let's get the future value of his payments. So in other words, if he just invested the money at the same interest rate, he would have got paid interest. And so that money would need to come off as well, the interest that he earns. So what you do is you say, well, we're going to take the value of the loan at 35 months and we're going to subtract the value of the payments that he's made. And so we use this purple formula here, the X, and so the payments were 9,000. 1 plus, okay, so this is a square bracket, 1 plus, I was, again, 15% over 12. Close brackets, and this was 35 months, minus 1, all divided by the interest, which is 15% divided by 12. I don't really have enough space, so I'm just going to write divided by 12. Okay, so I'm going to do these separately because this question is not too easy to kind of grasp. So we'll go up. So this was 7.4 here. And we're going to continue this question up at the top. Okay. So first we're going to say, well, what is the value of the loan after this after 35 months? So that's 256,289.06, open brackets, 1 plus, and then we've got our 15%. Was still the interest over 12. So the value of the loan in 35 months will be 39. So we're going to put that in blue. $395,873.2753. What we're going to do is we're going to subtract this value here. So what I can do is I can say minus. So it's going to be 9,000. Open our brackets. 1 plus, open a new set of brackets. 1 plus, and then it's the 15% over 12. Or you can put 0.15 if you want to. To the power of 35. And of course, we need to close the brackets now. Oops. Around the whole thing at the top. Then, did I do? Oh, using the future value of the investment formula. So it's not the 1 plus, it's the minus 1. You use the wrong formula here. Delete, delete. Okay, I'm using the one that I've circled in purple up at the top there. Minus 1. Divided by the interest, 15%. Oops. Okay, and the balance outstanding, that makes a lot of sense because it's it's got to be less than 9,000. Okay, and my calculator stopped working, which is just as well because we've done it. We've done most of it. Okay, so I'll close that. Cancel. Okay, so what was it? Oh darn. Let's see if we can start it up again. No, we can't. Okay, so now I have to just, because that doesn't work anymore, I'm just going to, I don't want to restart the program, so I'm going to just put this in purple, and when I put this in purple into this calculator, I get 392,137.827. Now I can subtract that from the 395,873.275, and I get, looks like I think the same thing that we got earlier, which was, let's put this in white. Final answer is 3735.45. Okay, now that is not the final installment because that is the value after 35 months. But of course, you're only going to pay that at the end of 36. So we need to just add interest of 1 month. So we'll just say 1 plus, and it will just be 15% over 12. So that's just the interest for 1 month to the power of 1. We'll just multiply that by 1 plus, and then we can say 15% over 12. And we get final answer of 3,782 and 14 cents. Okay, so that is your financial maths question. I promised you I would show you a little picture of a little precious one. So there she is there. And there she is. Okay, so yeah, if you like the baby, find the subscribe button down below, and I'll keep showing you videos, and yeah, support the channel. And we're going to be doing probably another balance outstanding question because that was what we just did there, but I want to do one more of those so that we are clear on that. And then, yeah, we are almost done with paper 1. We'll be doing statistics and then going on to paper 2. So subscribe so that you get notifications on when I do these videos, and I will see you soon.